Hello all, welcome to a new video on logic design. This video is about the SR latch using NOR gate, which is an important topic for your technical exam. The three cases in the SR latch have been discussed in the video. Watch the video till the end so that you can cover all the important topics explained in the video. If you are new to this channel, check out the videos on the selected topics from the course of Logic Design and the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So without further delay, let's get started. We know that the difference between a combinational circuit and a sequential circuit is the memory block. In the sequential circuit, you have a memory block. So here this latch is a sequential circuit. So the basic storage element is called latch. As the name suggests, it latches 0 or 1. The latch is used to store the bits 0 or 1. That means we can store multi-bits like 0, 1, 0, 1 or 1, 1, 0, 1, etc. We can store single bit 0 or 1, or if we can store single bit, definitely we can store multi bits like 0, 0, 1, 0, 1, 1 or 1, 1, 0, 1. Any bits we can store in this latch. So for this purpose, we use the circuit with two NOR gates. Here we are using two NOR gates. This is one NOR gate. This is another NOR gate. So we can use this circuit with two NOR gates. We can use NAND gates also in order to construct this circuit or this latch. We can use NOR gates or NAND gates. Here in this circuit I am using a NOR. So this is a disadvantage, that is we have to know which gate have been used inside the circuit. Now, as the name suggests, it is like latching the door of a room, but there is a difference in latching your door and latching your data. When you latch a room, anything inside the room cannot be taken out or anything outside the room cannot be let in. But in this case, if I change the input, that is, which are the inputs here? R and S are the inputs. R means reset and S is set. In your digital electronics, reset means 0 and set means 1. Set is 1 and reset is 0. Now, S and R, these inputs S and R, if it changes intentionally or accidentally, because we use this circuit along with other circuits, and suppose the output from that circuit to R and S changes, what will happen? The output also changes and S and R will also change and the stored data will be removed. So this is one disadvantage. That is, if I change the input S and R, if I change the input S and R, definitely the stored data will get changed. And as I told, this S and R changes, it can change accidentally or it can change intentionally because we use the circuit along with other circuits. Suppose this R and S is connected to another output and that output changes. Then S and R will also change and the stored data will be removed. So this is the disadvantage and we can overcome this by using clock. This will be discussed later. So why do we call these input as R and S? As I told, R means reset and S is set. So when you give the reset value as 1 in this circuit, you will get the output is 0. Output Q will be 0 when you give the reset value R as 1. Similarly, when you give set as 1, the same output Q should be 1. So we'll prove that when R is equal to 1, Q equal to 0, and when S is equal to 1, Q is equal to 1. So in order to prove that, I need to know the truth table of NOR gate. So what is the truth table for NOR gate? The truth table for NOR gate is, suppose A and B are the inputs and Y is the output. These are the combinations of input 0, 0, 0, 1, 1, 0, 1, 1. These are the combinations of input, and the output is, when both the inputs are 0, the output is 1. When 0, 1, 1, 0, 1, 1, when you give these combinations, the output is 0. So in the first case, I am going to give the input value for R as 1. So when I give the input value R as 1, you can see in the truth table, when the input value is 1, whatever be the other input, that is, in one case it is 0, the other case it is 0, sorry, other case it is 1, the output you are getting is 0. Therefore, Q is equal to 0. When you give R equal to 1 as the input, Q, the output, is equal to 0. Now, this 0 can be given as the input to the other NOR gate, and here the value of S is equal to 0. So when you give 0 and 0 as the input to the NOR gate, you will get 1 as the output. When you give 0 and 0 as the input to the NOR gate, here you will get 1 as the output. So when Q is equal to 0, Q bar is equal to 1. So in the first case, we have given R equal to 1, S equal to 0, so that we got the output as Q equal to 0 and the complement of Q as 1. Now we have to prove that this SR latch work as the memory element. For that, I am going to remove the values in R. I will make this as 0. Instead of 1, I am going to give 0 here. That is, I am going to remove the inputs from both the inputs, that is R and S. That's why I have changed R equal to 1 to R equal to 0, and the output remains the same. So here from this output, that is Q bar equal to 1, you will get the input to the first NOR gate as 0 and 1. So when you give 0 and 1 as the input, the output is 0. That is, Q is equal to 0. When you give S equal to 0 and R equal to 0, you will get Q as 0. And what about Q bar? That is, this Q will be given as the input to the second NOR gate, so that you will give 0, 0 as the input to the second NOR gate. So when you give 0, 0 as the input, you will get 1 as the output. That is, Q complement is equal to 1. So you can see that in the output, in both these cases, the output is the same. That means it has retained the output. Therefore, this works as the memory. Now, in the second case, we are giving S is equal to 1 and R equal to 0. So when you give S as 1, whatever be the second input, you will get the output as 0. Therefore, Q bar is equal to 0. Now, this output Q bar have been given to the as the input to the first NOR gate, so that the output from this NOR gate is, suppose 0 0 is the input to the NOR gate, the output is 1, that is Q is equal to 1. So when you give S equal to 1 and R equal to 0, the output Q is equal to 1 and the complement of Q is 0. Now I am going to give the values for R and S as 0. That is, we have to check whether this SR latch can be used in the second case also. When you give S equal to 1 and R equal to 0, the output that we got here, Q equal to 1 and Q bar equal to 0, can be stored, whether this can be used as a memory element. For that, let us erase the values which we have given for R and S, and here you have Q bar equal to 0. So when you give this Q bar as the input to the first NOR gate, you will get the output as 1. That is, when you give 0 0 as the input, the output is 1. And when you give this output to the second NOR gate as the input, that is 1 and 0, when you give 0 1 as the input, you will get 0 as the output. Therefore, when you give S equal to 0 and R equal to 0, you will get Q equal to 1 and Q bar equal to 0. That means it is retaining the output here. Therefore, this works as the memory. So the first and second case is very important. It has retained 0 and 1, the output 0 and 1 in the first case, and it has retained the outputs 1 and 0 in the second case. That is, it has hold the bits 0 and 1 in the memory. Now, the third case is very different from these two cases. In case 3, it is going to confuse you. That is, when you give the values, that is the input values as S equal to 1 and R equal to 1, we are giving in both the cases, that is for S and R, the inputs we are going to give is 1. What will be the output? What is Q and Q bar? So let me remove all these what we have given the inputs in the previous case. Now I am going to start the analysis from Q. Here I am going to give the input as R equal to 1 and S equal to 1. So we know that when you give the input as 1, whatever be the second input, we will get the output as 0. Therefore, here Q equal to 0 and complement of Q is also 0, which is wrong. That means each output should be the complement of the other. If Q equal to 0, Q bar should be 1. If Q bar equal to 0, then if Q equal to 1, then Q bar should be equal to 0. But here you can notice that Q is also 0, Q bar is also 0, which is wrong. Now let us consider another case. Suppose S is equal to 0, that means we are going to remove the inputs from both S and R. So when you remove this input, that means I am going to change this to 0 0. So when you remove the inputs from R and S, you will get the output. What would be the output? Here let me start the analysis from Q. So Q value is 0. So when you give 0 0 as the input to this NOR gate, you will get 1 as the output. and in this case Q is equal to 0 and Q bar is equal to 1. No problem in that. You are getting the value for Q as 0 and you are getting the complement of 0, that is Q bar is equal to 1 as the other output. Now let me start the analysis from Q bar. You forget all these things, this 1 and 0, this 0. Okay, so let me start the analysis with Q bar, from Q bar. So what is the value of Q bar here? It is 0. So when you give 0 0 as the input to this first NOR gate, you will get Q value as 1 and this 1 will be given as the input to the second NOR gate, that is you are giving 0 and 1 as the input to the second NOR gate. The output you get here is 0. So in this case you are getting Q is equal to 1 and Q bar is equal to 0. So you can see here in the second case you are getting Q equal to 0, Q bar equal to 1, and in the first case it was 0 0. That means it doesn't work as a memory element. And also when you start the analysis from Q bar, you are getting it as the output as Q is equal to 1 and Q bar equal to 0, which is wrong. So this is a bit confusing and therefore we are not using this, or this condition is not used. This case is not used. The case 1 and case 2 is important. The case 3 is not used in SR latch. Now you can form a table and summarize all the three cases. So here you have the inputs S and R and you have the output Q bar. Here when you give the inputs as 0 0, you can see here when you give S as 0 and R as 0, it has a memory. Similarly in the second case also, when you give S as 0 and R as 0, you have a memory. So you can write like this, memory, and in the combinations 0 and 1, you can see in the first case when you gave S as 0, R as 1, you got the output as Q equal to 0 and Q bar is equal to 1. In the next case when you give 1 0, that is S is equal to 1 and R equal to 0, your Q is equal to 1 and complement of Q is equal to 0. Similarly, when you give S equal to 1, R equal to 1, it is not used. We don't use this case in the SR latch. So this is about SR latch.